Voting theory. Example 7. Consider the voting system below. In this election, Carter would be eliminated in the first round and Adams would be the winner with 66 votes to 34 for Brown. Now suppose that the results were announced, but election officials accidentally destroyed the ballots before they could be certified, and the votes had to be recast. Wanting to jump on the bandwagon, 10 of the voters who had originally voted in the order, Brown, Adams, Carter, changed their vote to favor the presumed winner, changing those votes to Adams, Brown, Carter. In this re-vote, Brown will be eliminated in the first round, having the fewest first-place votes. After transferring votes, we find that Carter will win this election with 51 votes to Adams' 49 votes, even though the only vote changes made favored Adams. The change ended up costing Adams the election. This doesn't seem right and introduces our second fairness criterion. Monotonicity criterion. If voters change their votes to increase the preference for a candidate, it should not harm the candidate's chances of winning. This criterion is violated by this election. Note that even though the criterion is violated in this particular election, it does not mean that IRV always violates the criterion, just that IRV has the potential to violate the criterion in certain elections. Borda count. Borda count is another voting method named for Jean-Charles de Borda, who developed the system in 1770. Borda count. In this method, points are assigned to candidates based on their ranking, 1 point for last choice, 2 points for second to last choice, and so on. The point values for all ballots are totaled, and candidate with the largest point total is the winner. Example 8. A group of mathematicians are getting together for a conference. The members are coming from 4 cities: Seattle, Tacoma, Puyallup, and Olympia. Their approximate locations on a map are shown to the right. The votes for where to hold the conference were: in each of the 51 ballots ranking Seattle first, Puyallup will be given 1 point, Olympia 2 points, Tacoma 3 points, and Seattle 4 points. Multiplying the points per vote times the number of votes allows us to calculate points awarded. Adding up the points, Seattle, 204 plus 25 plus 10 plus 14 equals 253 points. Tacoma, 153 plus 100 plus 30 plus 42 equals 325 points. Puyallup, 51 plus 75 plus 40 plus 28 equals 194 points. Olympia, 102 plus 50 plus 20 plus 56 equals 228 points. Under the Borda count method, Tacoma is the winner of this vote. Try It Now 4. Consider again the election from Try It Now 1. Find the winner using Borda count. Since we have some incomplete preference ballots, for simplicity, give every unranked candidate 1 point, the points they would normally get for last place. What's wrong with Borda count? You might have already noticed one potential flaw of the Borda count from the previous example. In that example, Seattle had a majority of first choice votes, yet lost the election. This seems odd and prompts our next fairness criterion. Majority criterion. If a choice has a majority of first place votes, that choice should be the winner. The election from example 8 using the Borda count violates the majority criterion. Notice also that this automatically means that the Condorcet criterion will also be violated, as Seattle would have been preferred by 51% of voters in any head-to-head comparison. Borda count is sometimes described as a consensus-based voting system since it can sometimes choose a more broadly acceptable option over the one with majority support. In the example above, Tacoma is probably the best compromise location. This is a different approach than plurality and instant runoff voting that focus on first choice votes. Borda count considers every voter's entire ranking to determine the outcome. Because of this consensus behavior, board account or some variation of it is commonly used in awarding sports awards. Variations are used to determine the most valuable player in baseball, to rank teams in NCAA sports, and to award the Heisman Trophy. Copeland's method, pairwise comparisons. So far, none of our voting methods have satisfied the Condorcet criterion. The Copeland method specifically attempts to satisfy the Condorcet criterion by looking at pairwise, one-to-one comparisons. Copeland's method. In this method, each pair of candidates is compared using all preferences to determine which of the two is more preferred. The more preferred candidate is awarded 1 point. If there is a tie, each candidate is awarded half point. After all pairwise comparisons are made, the candidate with the most points, and hence the most pairwise, wins, is declared the winner. Variations of Copeland's method are used in many professional organizations, including election of the Board of Trustees for the Wikimedia Foundation that runs Wikipedia. Example 9. Consider our vacation group example from the beginning of the chapter. Determine the winning using Copeland's method. We need to look at each pair of choices and see which choice would win a one-to-one comparison. You may recall we did this earlier when determining the Condorcet winner. For example, comparing Hawaii versus Orlando, we see that 6 voters, those shaded below in the first table below, would prefer Hawaii to Orlando. Note that Hawaii doesn't have to be the voter's first choice. We're imagining that Anaheim wasn't an option. If it helps, you can imagine removing Anaheim as in the second table below. Based on this, in the comparison of Hawaii versus Orlando, Hawaii wins and receives 1 point. Comparing Anaheim to Orlando, the 1 voter in the first column clearly prefers Anaheim, as do the 3 voters in the second column. The 3 voters in the third column clearly prefer Orlando. The 3 voters in the last column prefer Hawaii as their first choice. But if they had to choose between Anaheim and Orlando, they choose Anaheim, their second choice overall. So altogether, 1 plus 3 plus 3 equals 7. Voters preferred Anaheim over Orlando, and 3 prefer Orlando over Anaheim. So, comparing Anaheim versus Orlando, 7 votes to 3 votes, Anaheim gets 1 point. Altogether, Hawaii versus Orlando, 6 votes to 4 votes, Hawaii gets 1 point. Anaheim versus Orlando, 7 votes to 3 votes, Anaheim gets 1 point. Hawaii versus Anaheim, 6 votes to 4 votes, Hawaii gets 1 point. Hawaii is the winner under Copeland's method, having earned the most points. Notice this process is consistent with our determination of a Condorcet winner. Example 10. Consider the advertising group's vote we explored earlier. Determine the winner using Copeland's method. With 5 candidates, there are 10 comparisons to make. Totaling these up, using Copeland's method, we declare D as the winner. Notice that in this case, D is not a Condorcet winner. While Copeland's method will also select a Condorcet candidate as the winner, the method still works in cases where there is no Condorcet winner. Try It Now 5. Consider again the election from Try It Now 1. Find the winner using Copeland's method. Since we have some incomplete preference ballots, we'll have to adjust. For example, when comparing M to B, we'll ignore the 20 votes in the third column which do not rank either candidate. What's wrong with Copeland's method? As already noted, Copeland's method does satisfy the Condorcet criterion. It also satisfies the majority criterion and the monotonicity criterion. So is this the perfect method? Well, in a word, no. Example 11. A committee is trying to award a scholarship to one of 4 students, Anna, Brian, Carlos, and Dimitri. The votes are shown below. making the comparisons, totaling. So Carlos is awarded the scholarship. However, the committee then discovers that Dimitri was not eligible for the scholarship. He failed his last math class. Even though this seems like it shouldn't affect the outcome, the committee decides to recount the vote, removing Dimitri from consideration. This reduces the preference schedule to totaling. Suddenly, Anna is the winner. This leads us to another fairness criterion. The independence of irrelevant alternatives, IIA criterion. If a non-winning choice is removed from the ballot, it should not change the winner of the election. Equivalently, if choice A is preferred over choice B, introducing or removing a choice C should not cause B to be preferred over A. In the election from example 11, the IIA criterion was violated. This anecdote illustrating the IIA issue is attributed to Sidney Morgenbesser. After finishing dinner, Sidney Morgenbesser decides to order dessert. The waitress tells him he has two choices, apple pie and blueberry pie. Sidney orders the apple pie. After a few minutes, the waitress returns and says that they also have cherry pie, at which point Morgenbesser says, "In that case, I'll have the blueberry pie." Another disadvantage of Copeland's method is that it is fairly easy for the election to end in a tie. For this reason, Copeland's method is usually the first part of a more advanced method that uses more sophisticated methods for breaking ties and determining the winner when there is not a Condorcet candidate. So where's the fair method? At this point, you're probably asking why we keep looking at method after method just to point out that they are not fully fair. We must be holding out on the perfect method, right? Unfortunately, no. A mathematical economist, Kenneth Arrow, was able to prove in 1949 that there is no voting method that will satisfy all the fairness criteria we have described. Arrow's impossibility theorem. Arrow's impossibility theorem states, roughly, that it is not possible for a voting method to satisfy every fairness criteria that we've discussed. To see a very simple example of how difficult voting can be, consider the election below. Notice that in this election, 10 people prefer A to B, 10 people prefer B to C, 10 people prefer C to A. No matter whom we choose as the winner, 2/3 of voters would prefer someone else. This scenario is dubbed Condorcet's voting paradox and demonstrates how voting preferences are not transitive. Just because A is preferred over B and B over C does not mean A is preferred over C. In this election, there is no fair resolution. It is because of this impossibility of a totally fair method that plurality, IRV, border count, Copeland's method, and dozens of variants are still used. Usually, the decision of which method to use is based on what seems most fair for the situation in which it is being applied. Approval voting. Up until now, we've been considering voting methods that require ranking of candidates on a preference ballot. There is another method of voting that can be more appropriate in some decision-making scenarios. With approval voting, the ballot asks you to mark all choices that you find acceptable. The results are tallied, and the option with the most approval is the winner. Example 12. A group of friends are trying to decide upon a movie to watch. 3 choices are provided, and each person is asked to mark with an X which movies they are willing to watch. Totaling the results, we find Titanic receives 5 approvals, Scream received 6 approvals, and The Matrix received 7 approvals. In this vote, The Matrix would be the winner. What's wrong with approval voting? Approval voting can very easily violate the majority criterion. Voting in America. In American politics, there's a lot more to selecting our representatives than simply casting and counting ballots. The process of selecting the president is even more complicated, so we'll save that for the next chapter. Instead, let's look at the process by which state congressional representatives and local politicians get elected. For most offices, a sequence of 2 public votes is held: a primary election and the general election. For nonpartisan offices like sheriff and judge, in which political party affiliation is not declared, the primary election is usually used to narrow the field of candidates. Typically, the 2 candidates receiving the most votes in the primary will then move forward to the general election. While somewhat similar to instant runoff voting, this is actually an example of sequential voting, a process in which voters cast totally new ballots after each round of elimination. Sequential voting has become quite common in television, where it is usually used in reality competition shows like American Idol. Congressional, county, and city representatives are partisan offices in which candidates usually declare themselves a member of a political party, like Democrats, Republicans, the Green Party, or one of the many other smaller parties. As with nonpartisan office, a primary election is usually held to narrow down the field prior to the general election. Prior to the primary election, the candidate would have met with the political party leaders and gotten their approval to run under that party's affiliation. In some states, a closed primary is used in which only voters who are members of the Democratic Party can vote on the Democratic candidates, and similar for Republican voters. In other states, an open primary is used in which any voter can pick the party whose primary they want to vote in. In other states, caucuses are used, which are basically meetings of the political parties only open to party members. Closed primaries are often disliked by independent voters who like the flexibility to change which party they are voting in. Open primaries do have the disadvantage that they allow rating, in which a voter will vote in their non-preferred party's primary with the intent of selecting a weaker opponent for their preferred party's candidate. Washington State currently uses a different method called a top 2 primary, in which voters select from the candidates from all political parties on the primary, and the top 2 candidates, regardless of party affiliation, move on to the general election. While this method is like independent voters, it gives the political parties incentive to select a top candidate internally before the primary, so that 2 candidates will not split the party's vote. Regardless of the primary type, the general election is the main election, open to all voters. Except in the case of the top 2 primary, the top candidate from each major political party would be included in the general election. While rules vary state to state, for an independent or minor party candidate to get listed on the ballot, they typically have to gather a certain number of signatures to petition for inclusion.